Space telescopes, where humanity learned to see the invisible dose. Before dawn, the universe looks quiet. Stars blinking through cold darkness, planets moving in silence, galaxies drifting like distant lanterns. But that calm is a lie. Space is chaos and violence, beauty and catastrophe, light and shadow interwoven across billions of years. And for most of human history, we saw only a fraction of it. Our eyes, our telescopes, our tools, all trapped beneath Earth's atmosphere, blurred by air, clouds, distortion, and the limits of visible light. Then came an idea bold enough to change everything. Lift the telescope off the Earth entirely. Put our eyes in orbit. Let humanity see the universe as it truly is. It begins long before launch pads or countdowns. Back in the 1920s, when an astronomer named Edwin Hubble used the Hooker telescope in California to prove that galaxies exist beyond the Milky Way. His discovery shatters the scale of the known universe. But even he knows the truth. Earth's atmosphere is an obstacle, warping light, hiding details, blocking huge portions of the electromagnetic spectrum. Radio waves slip through, visible light struggles, ultraviolet gets swallowed, X-rays die completely. The universe is talking, but from the ground, we're hearing only fragments. By the mid-20th century, rockets finally climb high enough for a radical shift. Scientists start attaching detectors to V-2 rockets captured after World War II, sending them above the atmosphere for seconds at a time. Those brief moments change astronomy forever. Suddenly, ultraviolet light pours in, X-rays burst through. The cosmos reveals high-energy storms and structures no one imagined. The message is clear. If we want to understand the universe, we have to leave the Earth behind. The tension grows, NASA forms. The Cold War accelerates innovation. Early orbital telescopes, like the orbiting astronomical observatories in the 1960s, circle the Earth capturing ultraviolet and X-ray data that ground telescopes never could. Then the dream coalesces into something bigger, a single, powerful space telescope designed to see deeper, clearer, farther than anything built before. The project gains momentum. Designers sketch massive mirrors and sensitive detectors. Engineers calculate orbits and solar arrays. Astronomers imagine images sharp enough to rewrite textbooks. That telescope will become Hubble. But Hubble's story is far from smooth. In April 1990, the Space Shuttle Discovery lifts off with the Hubble Space Telescope folded inside its cargo bay. The world watches with anticipation. Hubble deploys into orbit, panels unfurl, instruments awaken, and the first images arrive blurry. Not slightly blurry, catastrophically blurry. A minuscule flaw in the primary mirror, just 1/50th the width of a sheet of paper, warps the light. Years of planning. Billions of dollars. A world waiting for a cosmic revolution. And the telescope can't see clearly. The disappointment becomes global. Headlines mock it. Politicians question the program. But NASA moves fast. They design corrective optics, tiny lenses to counteract the mirror's error, and prepare a repair mission. In December 1993, astronauts aboard the Space Shuttle Endeavour anchor the telescope, replace hardware, install new instruments, and release it back into orbit. Weeks later, the corrected images arrive. Razor-sharp stars, swirling nebulae, galaxies colliding in fire and light. Hubble goes from near failure to staggering triumph. Its images become icons. Pillars of gas stretching like cathedral spires, supernova remnants blooming like cosmic flowers, but stars forming in clouds of dust that glow like embers. Then comes the Hubble Deep Field in 1995, a photograph taken of a tiny, seemingly empty patch of sky. The telescope stares for 10 days, gathering faint light. When the final image forms, astronomers are stunned. More than 3,000 galaxies fill a space the size of a grain of sand held at arm's length. The universe is far larger, richer, and stranger than anyone dared imagine. Hubble's success rewrites physics. It measures the expansion of the universe with precision. It helps confirm the existence of dark energy. It watches stars born, stars die, planets form, galaxies crash, black holes feed. Its influence reaches beyond science. Its photographs reshape culture. People print them as posters. Teachers show them in classrooms. Children fall in love with space because of them. Art and astronomy collide, but Hubble is only the beginning. Other space telescopes expand the spectrum further. The Compton Gamma Ray Observatory sees violent bursts of energy from black holes and neutron stars. The Chandra X-ray Observatory reveals cosmic collisions and the hot gas that fills galaxy clusters. The Spitzer Space Telescope peers into infrared wavelengths, exposing planets forming in dusty disks and stars hidden behind veils of dust. Each one adds a new layer to our understanding of the cosmos. Each one widens the universe. And then, decades after Hubble first changed the world, another telescope rises, not as a replacement, but as something fundamentally new, the James Webb Space Telescope. JWST unfolds like a mechanical butterfly in 2021. Its 18 gold-coated mirrors spreading open in the cold shadow of deep space. It travels nearly 1 million miles from Earth to the L2 point, a gravitational pocket where it can drift with minimal interference. Its sun shield, the size of a tennis court, cools its instruments to near absolute zero, allowing it to detect light so faint and old it is stretched into infrared over billions of years. The tension during deployment is unbearable. Mirrors must align with microscopic precision. Panels must unfold perfectly. Any jam, any snag, any misfire would doom the mission. But everything clicks into place. When JWST sends back its first images, a razor-sharp star surrounded by perfect diffraction spikes, the world exhales. Then the science arrives. JWST reveals galaxies formed just a few 100 million years after the Big Bang. It captures cosmic structures at the edge of time. It dissects the atmospheres of exoplanets, detecting water vapor, methane, carbon dioxide, chemical fingerprints of worlds that may hold oceans, clouds, or something more. It exposes star-forming regions with clarity so precise they look sculpted by light. It peers through dust that hid mysteries for centuries. Yet even JWST doesn't end the story. On Earth, massive ground-based observatories like the Extremely Large Telescope and the Giant Magellan Telescope are rising with mirrors the size of small houses, powered by adaptive optics that bend and twist to cancel atmospheric distortion in real time. Meanwhile, upcoming missions like the Nancy Grace Roman Space Telescope will map billions of galaxies, searching for signs of dark energy's strange grip. More telescopes, laser-powered, cryogenically cooled, shielded from sunlight, are being designed to study black holes, gravitational waves, and planets that may resemble early Earth. But the twist, the real twist, isn't about hardware or rockets or orbits. It's about perspective. Space telescopes didn't just let us see the universe. They forced us to confront what seeing really means. They showed us galaxies racing away at incredible speeds. They showed us stars forming in violent storms of gas. They showed us worlds beyond our solar system, some scorched, some frozen, some potentially harboring the chemistry of life. They showed us that the universe is not empty, but overflowing. Not quiet, but roaring with radiation and collisions. Not permanent, but in constant motion. They showed us our place. Because when Hubble photographed Earthrise over the moon, when JWST captured galaxies bending light around invisible mass, when Chandra mapped the hot plasma swirling across cosmic structures, one truth became clear. We're part of something vast, ancient, interconnected. Something that started long before us and will continue long after the last human story is told. Space telescopes are not just machines of science. They are mirrors reflecting our hunger to understand, our refusal to settle for the surface of things, our need to push past limits, even when the sky seems final. And that is the final revelation. The more clearly we see the universe, the more deeply we see ourselves. Every new telescope isn't just an eye-opening on space. It's a step toward understanding where we came from, where we're going, and how much of the cosmos still waits unseen for humanity to dare to look.